Good morning, everybody. Today we are going to solve practice problem 3.3 from Alexander Sadiku's Fundamentals of Electric Circuit. When this is the electric circuit given and we are asked to find V and I in the circuit. The answer is given. We solve the problem and verify the answer too. This is the electric circuit given in this here 14 ohm and 6 ohm voltage sources are available, and then 4 ohm, 3 ohm, 2 ohm and 6 ohms are available, and node 1 and 2 are already mentioned in the problem itself, and this voltage across this 3 ohm is also denoted as V in the problem itself, and this current I flowing through the 2 ohm resistance is also mentioned in the problem. Other than that, we are going to mention the currents using the notation as, so we take this as I1 current by ourselves, and we are going to take this as I2 current, and we are going to take this as I3 current. Okay, and then we have mentioned this as ground node, and in this problem we have one more concept that is called the super node or generalized node. What is the definition given for this? If any voltage source is connected between two non-reference nodes, then that nodes form a super node. So here already given in the problem is node number 1 and 2, but it comprises of a voltage source which is connected between non-reference nodes. Okay, please check this 14 volts, and this voltage source is connected to a reference node. But if you see this 6 volts voltage source, this is connected to one node which is non-reference node, and the other end is connected to this second node which is also a non-reference node. Okay, that means these two nodes are not directly connected to ground. Okay, so these node combination 1 and 2 node combination can be called as a super node. So in this case we need to apply both KCL and KVL. We know already the statement of KCL, or this last states that the sum of incoming currents is equal to sum of outgoing currents. And for KVL, the sum of all voltages in any closed loop is equal to 0. Okay. And other than that, we are applying this Ohm's law also. We have noted this voltage at node 1 as V1 and node 2 as V2. Okay. Now we'll try to solve this problem. At this super node, which comprises of this 1 and 2, right? So this forms your super node. And in this supernode, we can write the equation as V1 minus V2 is equal to minus 6, because it is starting from here and ending here. Okay, in between the 6 volt is there, but here this minus sign is in front of it, right? Because this is minus and this is plus. So we can write this as minus 6. So this is our first equation. So the second, we are going to apply the KCL at the super node. So we know that this is our super node, and in this node we are going to apply the KCL. So what are the incoming currents for this node? That is I1 is the incoming current and the other currents are leaving current. So we can write I1 is equal to this I2 plus this I plus this I3. These are all the leaving currents at that node. So this I1 can be written as, at this end you know that it is 14 volts available, right? So it is 14 volts. So we can write this as 14 volts minus this first node voltage put. Okay, so it is V1 divided by that resistance is 4 ohm. So I2 current, if you take this as your I2 current flowing through this branch, so that is V1 minus 0 potential divided by that 3 ohm resistance. And also you should know that that V1 potential is equal to that V in this problem. Okay, so I current that is existing in this branch, so it is V2 minus 0 potential divided by the 2 ohm resistance plus, what is I3? I3 current is, again it is from this second node. Okay, so because it is directly connected here, second node which is available at potential V2 minus that 0 potential divided by that 6 ohm resistance. So now we can write this as 14 by 4 minus V1 by 4, that is equal to V1 by 3 plus V2 by 2 plus V2 by 6. Okay. So if I bring everything to this side, it is 14 by 4 minus V1 by 4 minus V1 by 3 minus V2 by 2 minus V2 by 6. That is equal to 0. So here, if I take this 24 as common denominator, so it is 14 into 6, 84 minus 6V1 minus 8V1 minus 12V2 minus 4V2, that is equal to 0. So it is 84 minus 14V1 minus 16, okay, V2, that is equal to 0. So if you divide everything by 2, you will get this as 42 minus 7V1 minus 8V2, that is equal to 0. I can write this as 7V1 plus 8V2, that is equal to 42. So this is our second equation. Now bring the first equation. So it is V1 minus V2 is equal to minus 6. So bringing the first equation, V1 minus V2, it's equal to minus 6. Bringing back this and multiply this first equation with this 7, then you will get this as 7V1 minus 7V2 minus 42. So you make it as third. Now if you solve these two using elimination, whether this is minus, this is plus, this is also plus, okay. So second and third equation, so these two get cancelled and here you get this as 15V2, that is 84. So what is V2? V2 is equal to 84 by 15. So 84 by 15 is equal to 5.6. So what is the answer we got? We got V2 as 5.6 volts. This is the node voltage we got as answer 1. And then we have to find out what is V1, right? For that we can refer this first equation again. So V1 minus V2 is equal to minus 6. So in that if you substitute V2, then you will get V1 minus 5.6. This is equal to minus 6. So that is V1 is equal to minus 6 plus 5.6, that is equal to minus 0.4 volts. So V1 is equal to 0.4 volts. So in minus 0.4 volts, this can be written as minus 400 millivolts. In this problem given, I have already told you that this V1 is appearing here as this V, isn't it? So that we can mention this V1 is equal to V, that is equal to minus 400 millivolts. So we got this answer. Now one more question we have to solve, that is I. So I is what? V2 by this 2 ohm resistance, isn't it? So we have to find out I current. So that is V2 divided by 2 ohms resistance. V2 we have already calculated as 5.6 volts divided by 2. So it is 2.8 amps. So this I current is 2.8 amps. So this is one answer. This is the next answer we got. Now